Okay, Assalamualaikum and a very good morning to all students in Kuliah 3. So this is our video lecture for chapter 4. So I'll start. Okay, so chapter 4 will cover polynomials. So polynomials, I think this is a new chapter for all of you. Okay, so in this chapter we will cover 4 subtopics. Polynomials, we will look at what is polynomials first, basic introduction and so on. Then we will look through what is remainder theorem, vector theorem, roots and zeros of polynomials. Okay, so first of all, we look at polynomials first. Okay, by the end of the lesson, students should be able to define what is polynomial and state the degree of a polynomial and the leading coefficient. Okay, to recognize monomials, binomials and trinomials. What are these three? Okay, number 3 is to perform addition, subtraction and multiplication of the polynomials. Alright, and then lastly is to perform division by division of the polynomials and write the answer in this form. Px equals to qx multiplied with dx plus rx, where px is your polynomial, your original polynomial. Okay, qx is your quotient, dx is your divisor, rx is your remainder. Okay, we will look through what are these three equations. Okay, for basic introduction, basic function, first you must know what is a constant function. So constant function is defined by fx equals to b. Usually you know it as y equals to b. Okay, where in the graph, when you sketch the graph of basic function, constant function, this is your x, this is your y, right? So now it will become an fx. Okay, so fx now equals to b. So this will be a horizontal line. Okay, this will be a horizontal line. Okay, wait a minute, where is the pen? Okay, this will be a horizontal line. Okay, and then fx equals to ax plus b. Ax plus b is a linear function. Okay, last week we learned this equation as ax plus b equals to 0. So this is our linear equation. And then third is ax squared plus bx plus c, where this is we call as quadratic function. When you put it as equal to 0, equals to 0, then it will become quadratic equation. And then last is ax cubed plus bx squared plus cx plus d, where this is a cubic function. And this cubic function, when you equal it to 0 like this, like last week, then it will become cubic equation. So all these functions are special case of the general class of function. We call them as polynomial function. So this is the definition: polynomial px of degree n. Okay, remember degree n is defined by px equals to an xn plus an minus 1 xn minus 1 plus up until you get a1x power 1 here plus a naught, where n is a integer, positive integer. Okay, so just now, like for example, our cubic function, right? Fx equals to ax cubed plus, okay, if you are using this definition, this one will become a3, and then a2 x squared plus a1 x1 plus a naught. Okay, where all the coefficient is a coefficient of the polynomial. Okay, so please note that the coefficient of the highest power of x, an, is called leading coefficient. So this is the term that you must know. And then a naught is the constant term. And then the third one is the degree of the polynomial is determined by the highest power of x. Okay, if the highest power of x is x cubed, then we call the polynomial as a polynomial of degree 3. If power 4, then it will become polynomial of degree 4. Okay, so these are the example of polynomials. So you can look through here. Okay, this one px equals to negative 7, degree 7, because here is x power 0, right? So degree 0, constant. This is a constant function. So leading coefficient just now is the coefficient of the highest power of x. So in this case is negative 7. So here should be negative 7. Constant term is negative 7. Okay, how about the fourth example? This is power 3, polynomial of degree 3. We call it as cubic function. Leading coefficient is 2. Why 2? Because 2 is the coefficient of highest power of x, x cubed. Constant term here is this one, plus 3, right? Okay, so these are the example of non-polynomial expression. Okay, non-polynomial expression where the power is not an integer. Just now our n must be a positive integer. So in this case, this is not. Okay, 1 over 3 is not z positive. Okay, same goes to negative 1. It's not the element in z positive. Z positive start from 0, 1, 2, 3, and so on. Okay, all right. So what is monomials, binomials, and trinomials? Okay, so polynomials with one term we call as monomials. 2 term we call as binomials, 3 term we call as trinomials. So for example like this, monomials, 1 term. So if we are defining this monomial based on the definition, this is actually you have x cubed plus 0, x squared plus 0, x plus 0. But since all the coefficient of 0, so that's why we didn't write it down. So it only left one term. Then we call it as monomials. Okay, next. In polynomials also they have operation. So operation, they can have addition, subtraction, multiplication, and division. So these are the laws that you must know. You please check the previous note. What is commutative, what is associative, what is distributive. Alright, we first look at addition and subtraction. So if you have a polynomial, px and qx, okay, we can perform the addition and subtraction by collecting like terms. Okay, how is it? We'll look at the example. So if you have px 2x4 minus 5x cubed minus 4, okay, this is your px, polynomial x, and we give you another qx polynomial defined as qx, so this is the qx. So what is the addition of both two polynomials? Okay, first we write down our px, then qx as well. Then collecting like term is you are adding the term that have same x power of 4, and then this one you add together with the one that have x power 3. Okay, and so on. So 2x4 plus x4, you have 3x4. Negative 5x cubed plus x cubed, get this one. And then in this, the first polynomial here is actually plus 0x squared plus 0x before minus 4x, right? So 0x squared plus 3x squared, then you get 3x squared, just like that. Okay, how about subtraction? Okay, everything is in the bracket, then this is the minus sign. So when you open the bracket like this, so this one will become minus, right? Minus. Then we minus the similar term. Like this one, 2x4 minus x4, then you get x power 4. Negative 5x cubed minus x cubed, then you get negative 6x cubed. So this is the final answer lah. Okay, because they have no more similar terms, so this is the end of the answer. No need to simplify or anything. Okay, So how about multiplication? So multiplication is just multiply every term by each term in the other polynomial. Just like you are multiplying two brackets. For example, a plus b, a plus b. Okay, and then a multiply with a multiply with b. So we have a square plus ab, and then b multiply with a plus ab plus b square. And then we simplify. Similar term is just like this. Okay, ab plus ab is 2ab. So a square plus 2ab plus b square. Okay, example. Look at here. You have px, you have qx. Okay, the first question, multiply 4qx. So equals to 4 is a constant. What is your qx? 2x cubed minus x squared plus 1. Then you expand, multiply inside. So what you get? 8x cubed minus 4x squared plus 4. That's all. Then how about this one? Okay. X squared minus x minus 1 multiply with 2x cubed minus x squared plus 1. Then you multiply one by one. Expand everything. Okay, you just expand. Then you collect similar term and simplify. Okay, I think this is easy. Okay. Okay, now please take note that if your polynomial px is a degree m and your qx is degree n, okay, when the product of these two is a polynomial of degree m plus n. Okay, for example, like this one, px is a polynomial of power 2. Okay, qx is power 3. So product of these two must be the addition of these two power. 2 plus 3 is 5. So that's why you have a polynomial of degree 5. Okay, next we look at division. Okay, division. The division of the polynomial can be expressed in the form of px equals to dx. dx is divisor, qx is quotient, remainder is rx. Okay, for example, we will look at a real number first, 35 over 2. Okay, so 35 over 2, we do long division. 2 times 17, you get 34. Remainder 1. So how we write this long division in this form? You will have 17 from this answer. So this is your quotient. And then plus 1 over 2, remainder over divisor. Then this number 2, right? You bring here, multiply and multiply. So what you have? 17 times 2 plus 1 over 2 times 2 cancel out, then you left only 1. So this will give you px, the general equation, qx, this is dx plus remainder rx. Okay, easy kan? Senang ni. Okay, for example, now we will look at how we do for polynomial. So we do 2x squared. 2x squared plus 3x minus 6. So divide by x plus 1. Okay, so first is we want to remove this 2x squared. We have to remove this 2x squared. But then you look at here, you have x. So x multiplied by what number, you get 2x squared. You multiply with 2x, right? So 2x multiply with x, you will get 2x squared. 2x multiply with 1, you akan dapat 2x. Then you do subtraction process. Okay, and then 2x squared minus 2x squared, you get 0. 3x minus 2x, you akan dapat x. Then you put minus 6 down here, x minus 6. Okay, then how we want to remove this x? So you have x here, so here must be multiply with 1. So 1 times x, you get x. 1 times 1, you will get plus 1. And then you minus, right? So you akan end up dengan negative 7. So negative 7 is your remainder rx. Okay, so you will have this. 2x squared plus 3x minus 6 over x plus 1. Then this x plus 1 you bring to the other side. Okay, multiply and multiply here. Then you will have, this is your px equals to your quotient qx divisor dx plus your rx rx in this term is negative 7. Okay, your remainder. Okay, how about this one? You have 2 factor at the denominator. So back to your real number. Let's say you have 8. You want to divide with 2 times 2. Okay, so either you do 1 by 1, 8 divide by 2, then you get 4. Then you do another long division, 4 divide by 2, you do 1 by 1 kan. Ataupun you multiply the denominator first, 8 over 4. Barulah you buat long division itu 1 time, 2, 8 kan. So same thing with this, you can expand dulu yang di bawah tu, plus x cube plus x plus 6 over, okay, yang di bawah ini adalah x square plus berapa, 3x, 4x plus 3. Then baru kita buat the long division di sini. Okay, nanti you look through inilah, x square, because they want to remove x4, here is x square, so they must multiply with x square. So if you look at here kan, our question x square x4 plus x cube plus x. Suppose you have 0 x square di sini kan, in between. So when you do long division, you add that term. So that you can avoid confusion, because after you multiply dengan yang ini, x square multiply by 3, you akan end up dengan term coefficient of x square. So if you didn't write this, you akan confused. You akan tolak dengan nilai yang mana satu. So better to write that 0x square. Okay, so that's all for basic. It's not so basic because it's include the operation. So this is for the operation addition, subtraction, multiplication and division. So make sure you master this long division first, then only we can proceed with subtopic 4.2. Okay, I stop here, so later you check the second video. Okay, see you.